All right, so today, the 5th, we're still working on factoring trinomials, but here's the deal with the papers I just passed out. Chapter 9, your surface area volume paper. The main issue, you don't have to get it back out. The main issues that I was concerned about is people struggling to find the values coming from pyramids and cones and spheres, because those are like our awkward shapes, our weird formulas. And on the back, there were some conceptual understandings I wanted to make sure that we were actually clear on. 17, I kind of made a freebie because it's like so loosey-goosey. Most of you had it all right, but I just decided to just like let it go. So it's just corrections. I'm probably going to give you time at the end of class today. Because all we're doing, my plan for class today is just finish the 11.6 notes, taking as long as we need. Take any questions in 11.6 homework, give you guys time. So that's my plan for class today. So chapter 10, you guys should have all had the other form if you had it progressing. If you still are progressing on chapter 10 and you don't have the other form, let me know. But I'm updating math here really soon. And we're going to have a couple chapters drop in because I didn't put that much into quarter 2. I just didn't want to keep anybody here, and quite frankly, quarter 2 gets really busy, so I just didn't put the grades in. So, watch math in the next couple days. I will not do it today. I do not want to hit your parents with a report of like, wait, what is this? So I'll wait until at least this weekend to put grades in and update that stuff. So if you give me stuff back tomorrow, I'll grade it before I put grades in. Peace. So we were here, and to talk about this problem, I kind of wanted to show another reference problem because this has some negatives and that makes it a little bit more complicated. So check this out. This is another way that we can solve these trinomials. So we first find AC, and we don't just find like the coefficient value times the constant. We actually take the entire value of ax squared times the entire value of c, and we get a term. Now that term indicates to me what the product of my center of two terms should be. Now all this to say, we're solving this in one way. It can be solved multiple ways. So you would not have to take this way, but it's another option. One thing that we recognize is I can factor out the same binomial from both this binomial and this binomial can both be factored to leave an x plus 4 left over. If I do that, then because x plus 4 is common, I can take my coefficients to that common binomial and they become a new binomial. So x plus 4 is its own part of the FOIL, and the 2x and the positive 3 become the other part of our FOIL, or other binomial. This is just another method that we can take. So if this is, and we're going to practice this a couple times, but if this is confusing, you don't have to take that method. It's just another option when you see I can factor out the same binomials from both. So if we want to try to apply that, it's still up there, it's on the TV. So if we want to try to apply that here, and we kind of started chatting about this a little bit, our AC here, or not even quite AC, but our product would have been negative 14x squared. That is what your middle two terms are going to give you. So that breaks down to your x and your negative 14x. From there, we still have the original 2x that we had, and we still have the original minus 7 that we had. We just broke up that middle b term. Any questions on how we got just to right here? Just broke up the b term. Then, sorry, sit still. Yeah, we're looking at it slightly differently now. So from there, I kind of, and I'll highlight to do this, but you guys can like draw a split line or something. I split this into two different binomials. I'm going to look at my 2x squared minus x and my negative 14x minus 7. What our goal is here is to find a binomial that can be left over from each of these. Well, I only have a value of 1x here, so I know that I'm probably going to need to use 1, so I go ahead and I say 1. Well, what would need to multiply with 1 to make it 1x? Well, an x. So an x goes out front. And then what would that need to distribute into to make your 2x squared? A 2x. And if I can get this 2x plus 1 out of this binomial, then I'm good. So where my answer turns into, and this is why this is not finished here, I have the shared binomial of 2x plus 1.
Good afternoon. Andrew Hoover, please come to the office. Andrew Hoover to the office, please. Thank you.
That's going to end up multiplied by what? Huh? The x and the negative 7 to x minus 7. That's just one other way that we can do this. Now, yesterday, I believe that we looked at it, the method where we also, did we end looking at like the x method where we kind of did the array?
Yes.
Yeah. So that's another way we could solve this. There's many right ways. I'm just trying to give you guys options. The other way is just guess check. I mean, really, when I got taught this, I totally did not understand what I was doing. And a lot of my solving for this was just set up two parentheses, start plugging some things in. I know I have a 2x, so I can't multiply two things to get 2 unless one of them is 2 and one of them is 1. So I start to figure out what restraints do I have. Those have to exist. That has to be there. Without any of the knowledge about AC or B or any of that multiplication, those have to be there. Are you with me on like just, if I didn't know anything else, I can figure out that the 2x and the x have to be there. Then I just would start playing with things and say, okay, I need to make negative 7. I know one term's got to be positive, one has to be negative. So I would sometimes put that symbol there and say one's positive, one's negative, I don't know yet. And then I'd play with it and say, okay, one of these needs to be 7 and one needs to be 1. How can I make that work out for me? Well, my middle term is a negative, so the negative is stronger. So that would then tell me, okay, this has to be the negative, which means this has to be the positive, and then check it, does it work? Sometimes it doesn't. You fall apart and you start over and change some numbers, whatever. So there's always like multiple methods. Obviously, the guess check's not the best, but if you lose all knowledge, just start building my two binomials and start filling in what has to happen. Any other questions about problem 3?
What's easiest for you?
Now, I like array multiplication, especially because nobody ever showed me array multiplication when I was a kid. It wasn't that popular. We were very like, we teach math as Americans teach math, and now we realize like, oh, other countries have better methods. We should steal those methods and use them over here. So now we teach you guys slightly different than we used to. So either the array method or like that, the X is essentially the array method too.
Depends on how well you do.
Depends on how your brain processes.
Let's say
All right, I don't know what's going on. So move on to that got it. You can use whichever method you choose.
Can you use my first calculator?
Yeah. And all of the methods that we've discussed do have some similarities in them. everything here is positive. So that makes it slightly easier. When we start breaking this apart, one issue that we have is that 8x, that's a big coefficient. That leaves me a lot of options as I start to build my two binomials. Anyone confident in what they've done, able to help me out? First explain a little bit, Emma. 10 and 12. So we think about multiplying to make 120 and adding to make 22x. So the only difference really between the A, C, and B comparison method and the one that we just talked about is here we take into account the x's and we realize that 10x and 12x makes 22x. 10x times 12x makes the 120x squared. So I'm going to use 10 and 12. So that really then rewrites my function, because really we're dealing with a function. Now here's the interesting thing here. Yesterday, we talked about how the order here doesn't really make a difference. Now that we have that new method that we just looked at, finding a common binomial that can come out, the order can matter. So if we think about one of these, the 10x or the 12x, that can work with the 15, well, either of them could. The 10 could have 5 factored out of it, but the 12 could have 3 factored out of it. And either of those could work with the 15. So if we want to take the method that we just discussed, let's play with this for a second and figure out, well, what could be that common binomial? And then we would need to figure out what gets factored out. So a common binomial, well, it couldn't have an x at the end, because this doesn't have an x at the end. If I factor out a 3 from these guys, what would I have left? 4x and 5, right? Is there a way to get 4x and 5 here? Factor out a 2. Yes, thank you, because this has my power of 2 and then my power of 1. So then, that 4x minus 5 is one of your binomials, because it was common. That, thank you. That got multiplied by 2x and got multiplied by 3. And that's how we use that.
If I did 2x,
Yeah.
you could flip them and it would still work.
That's exactly where I was going next. It freaks me out sometimes that you're like telepathically.
Why?
I call him Math Jesus.
That and your parents have just set you up with a really good brain that is thinking through, okay, what can we, why are you not working
He
now?
has the mind capacity of a dog.
Everybody just punch it. You're working.
Maybe it would be more of a compliment if you were like his mind capacity. Like, what if it's a really bad computer? What if it's a calculator that for like $75? That's better mind.
So hey, take a second. If, hold up, come back to me. If we had flipped these middle terms around, now do you know what question I'm working towards?
Does it always work?
Does it always work? Will it, really my question was going to be, will it ever matter which order these are? But okay, so Calvin says, we could have had these in the other order and it would have been fine, so let's try that. 12x and 10x. What then, and I like to look here first because the constant kind of is a restraint. What would we factor out for the 10x and the 15? 5. You cannot divide 15 by 2 evenly. So we get 2x plus 3. That's a positive. And we need 2x plus 3 to be the same. Can we get it? What do we factor out? 4x. I end up with 4x and 5 and 2x plus 3. Same thing. The order of the broken up middle term. What we just discovered here didn't matter in this problem. The question that I want you guys to think about, and as we do the homework, it'll probably become more evident, is does it ever matter? Will that order make a difference? Like, say one of these is positive, one of these is negative. Does it ever set up a situation where I have to have one in a certain... I'm not looking for an answer right now. I'm just throwing you on with it. No, but it's another one to have in your toolbox. Sometimes this is easier depending on what the trinomial is. And especially if there's a trinomial where I can factor out a monomial first, hey, problem 4. It also changes things slightly.
Wait, what?
Like Macarena.
My mom forced me to dance the Macarena with her yesterday.
You make that sound like it's a bad thing.
Because she just yelled, family dance night.
Your mom's awesome, dude. I don't know why the Indian accent makes it that much.
All right, check out problem 4. So this is kind of obvious because the header of the section. But before we start trying to factor this trinomial, we can actually pull something out of all of them.
3.
A 3. So this can become 3 times
6x squared minus 11
That's a
plus
great voice.
4.
Should use that all the time.
Woo! Got it. Got it.
One explosion, 2 explosion.
Can we chill, guys? Now, what do you think we should do?
So,
How? Now, I taught this for like a day and a half, so. How?
Would you factor it normally inside the parentheses and then reapply the 3 afterwards?
Forget about the 3 for a minute. He doesn't matter.
Numbers.
In here, we can still treat this like everything else we've been doing. So I still have my 6x squared. I still want to break up my middle term. So what would that need to break up into? Michelle? Why? So your AC is 24, and if you bring the x with you, it's 24x squared. Your B is negative 11x. Carmen? Negative 8, negative 4. So,
Negative 3.
did you say 4 or did I just make that up? Okay, maybe I just made that up. And 8 and 3 will multiply to make your 24, and a negative times a negative makes it positive. Yeah. It's on the should be on the table unless somebody stole it. It's right there.
Oh, I didn't see it.
And then plus the 4. Can we factor something common from the 3x and the 4, or the negative 3x and the 4? If I flip the order of them around, could I factor something with the negative 8x and the 4? And the 6x squared and the negative 3x?
Yeah.
Oh, wait, yeah.
So this, if we want to use the method that we were just using, so I familiarize you guys with that a little bit. Now, we're going to come back to does it matter? Is there a way to do it another way? But if I make this negative 3x, negative 8x, let's see if that helps me at all. So this will still have the 3 on the outside. From 6x squared and 3x, you could factor out. Actually, let's go to our constant first and deal with that guy. 8x and 4, what do we factor out? You want to factor out a 2 or a 4? Let's try 4 first because it's our biggest. It won't always necessarily be the greatest, but we want to try that first.
Okay.
Would it be easy? Is it? Would the greatest make it?
It depends on what happens over here. So that, because remember, we have to have a matching binomial. We have to have a common binomial. So now we're looking for what can factor out,
What is the point
And-
of double parentheses on the right?
because there's two opened.
Oh.
If there's two open, you
Wait,
have to have two
Wouldn't
closed.
it be 4 negative 2?
Good, thank you.
Oh.
I was going to leave it positive x, and then I knew you guys would see that. So I made it negative x. So it's really negative 2x.
Wait, is it plus?
Thank you. I made a bunch of mistakes.
I was just thinking, I was just confused.
Now, trying to make sure that we're paying attention. And I'm hot, so I feel like I get kind of ornery when I get. I'm sweating up here. This is not good.
Is that why you have a fan?
Yes, but it's not doing anything.
Oh my gosh.
I'm very angry.
You are very angry today.
I'm hot. I can't deal with being hot. Mrs. Goldring and I have had this discussion over and over again. It's like 20 degrees outside. That like if the temperature in here worked how it was supposed to, we wouldn't really have any complaints about Phoenix. Like aside from windows, but that we can get over. But yeah, the heat is the only issue. Can I get this one to factor to a negative 2x and a positive 1?
Yeah.
What would need to be factored out?
3. Wait, 3x. No.
No.
Yeah, 3x.
No.
What am I doing wrong?
Calvin says look at it.
I don't.
I'll take a little bit of blame here. That 2 is kind of merging with the minus. So realize that this is 6x squared minus 3x.
It's negative 3x.
So if I factor out a negative 3x,
Thanks, Calvin.
Well, even if you didn't see that, you should have known because the positive 6x needs to turn
Right,
into
it
negative
needs-
6x.
No.
Yep.
My common skills are.
So now, hey, bring back one last step. 3 still on the outside.
Would it be? Oh, never mind. Wait. Oh, never mind. I'm good.
Negative 2x plus 1 is one of my binomials. Negative 3x plus 4 is the other one of my binomials. If we hadn't factored out the 3 to begin with, this would still work, but the values would be quite large and cumbersome. So it is better to analyze it first, figure out what can you factor out of all of them. So try the got it on your own for a second. You can use whatever method you want, but we do need to factor out a binomial first.
Wait. Shouldn't you reapply the 3?
You can actually leave it just like this if you want.
I think it would-
Like we can reapply the 3. So what would this turn into if we bring the 3 back in?
Some. All of my numbers are of the wrong sign.
What do you mean? Like, did you reapply the 3 and now you have wrong sign, or what?
I had it before.
You didn't factor out a negative 3 in the beginning, did you? So let's talk through the process. When you broke your negative 11x, did you have negative 3x and negative 8x?
Yeah.
Then when you came down here, did you factor with a negative 2x plus 1 in the
I didn't
parentheses?
do it like that.
Did you do positive 2x minus 1?
Yes.
And then you did a positive 3x out here,
Yeah.
and this was a negative 4?
Yeah.
It'll still work.
Okay.
Because the signs compensate for each other. So if every sign is the opposite of what this is, it'll still work.
Okay.
Yeah, you're fine. Other questions? So what we just, if you missed what we were saying, which I think some of you did, Calvin said, wait, all my signs are the opposite. That's fine. Because if here you factored out a negative 4, this would have been positive, this would have been negative. Then this would have been positive, this would have been negative to match, and this would have to be positive. So, Calvin, your 3 is positive, though, right? Okay. Yeah, as long as your 3 is still positive, all of these could have different signs and we'd be fine. As long as every single one had a different sign. Yeah.
Question: what are we doing now?
What do you mean?
Like, what are we even doing?
So yesterday when we looked at Desmos and we looked at what it's actually, actually let's look at the got it and then we'll plug it into Desmos and play with it for a minute.
No, I'm saying like what you have the equal sign.
Oh, well, he asked, should we reapply the 3? And so we can. We don't need to.
Oh, okay.
So-
I was confused. I was like, what are we supposed to be doing?
Yeah. So we could bring the 3 back in, but we really don't need to. We would leave it like this because this is honestly simpler. And if we need to reapply the 3, like if we wanted to just look at the 2 binomials, we could multiply everything by 3.
Wait, would that be like a accepted answer for like something like they got it in problem 3? Like if we like were to factor it out.
Problem 3.
I don't even know if we.
No, because it doesn't have a monomial that can factor out first.
But like I'm saying like.
If you could, yeah, that's an acceptable answer. So let's play with this for a second then. If we bring the 3 back in, and this would be negative 6x plus 3 minus 9x plus 12, what we want to ask is, does this still work out correctly?
Yeah, it works out. Wait, no. Wait. Then if you did the last part of it, that'd be 3 times 12. Why
Look
am
at your firsts.
first negative?
Negative 9 times negative
It makes
6.
sense.
Yeah.
That would equal
So what's the issue here?
you apply.
Why?
Yeah.
What needs to happen? What needs to change?
Oh, I thought you purposely. I thought you
Wait,
said
hold on.
spaz for a second. That's what I was thinking when I did it.
You can't. This is why we leave it like this. You cannot do this. That is not valid. Because that is not 3 into every part of those parentheses. That's 3 times the quantity of that binomial times that binomial. Because if we work backwards, these parentheses protected everything happening inside of here. So when we got down to here, really what the assumption is, when we write it without the red parentheses, we're assuming that we're going to multiply the binomials before we do anything with the 3. So when you ask about bringing the 3 back in, really, just leave it like this. It's better that way. Because to bring the 3 back in, you have to evaluate the binomials together. Or bring it in differently, and it's just easier to leave it like
So
this.
if you evaluate the binomial, will you just get the answer we had up there, right next to the 3, like very top?
If you evaluated.
Like if you actually saw, you said you had to evaluate.
So if you multiply these binomials together,
you get
is what-
the answer we had up
you
there.
get this.
Okay.
Now, the other question to pose, though, is this.
Okay, well, I was going to say,
Go
also
ahead.
if you don't put the red parentheses in, doesn't it just assume you're just multiplying it by the first?
So then we'd be working left to right. That's exactly where I was going. So what if we only applied the 3 to do negative 6x plus 3 and left my negative 3x plus 4 alone? Does that work now? This, if you want to put the 3 in, negative 6 times negative 3, positive 18x squared. Negative 6 times 4, negative 24x. Negative 9x, put them together, that gives you the negative 33. 3 and the 4 give you the 12. So if you go to put the 3 back in, you gotta realize it only goes to the first parentheses.
I was gonna say like. Really,
Yeah.
oh,
I was like, I'm going.
I wanted it to make a mistake so we could talk about why. So that
okay. Yeah. C.
questions. Try, you got it on your own. What about? Did you say you're so confused? Oh, I'm sorry, I agree for what it's worth. I worked on the rock wall last night
Are you making one?
at Lifetime. No, like I have like a second job kind of. I work like a night or 2 a week, but I get a free gym membership out of it
Okay, so you get a free gym membership?
What's that
at
shape?
Lifetime.
I wish I did.
What's the what?
The thing behind your black. When are you turning red?
I'm about to get swole.
That shape in chalk. Written on the blackboard.
This
Yes.
is a drawing of the rock wall that I work at.
Ah.
Because I was talking to somebody about climbing around the world. which is you start on the basketball floor, and you have to climb this rock wall around. You boulder, so you climb side to side as bouldering, and then you walk across the windowsill. You climb on this, you boulder all the way across, walk across the windowsill, and boulder all the way back around here to the basketball court. If you do that without touching the ground, you get the around the world, which then you get to write your name on the board. And so that's a challenge I was talking to
Does
somebody
it
about.
stay there forever?
For the year. So we just reset for 2017. It's real tough. I need to get a pair of shoes to probably do it, like climbing shoes to be able to do this.
I don't
No, not a pair of shoes.
How big is it?
Pretty big. Come check it out. Monday, Wednesday. Not every Monday, Wednesday, but I'm like every Monday this month and every other Wednesday. Because that's when the kids club comes, and I work well with kids. So last night it was me and 9 kids for an hour. I was the only person working last night. It was a little overwhelming.
How much do you work out?
My membership hasn't pushed through yet, but I like climb while I'm working. Like if no one's on the wall, I can just climb. I can do whatever I want. I can grade papers too. That's what's great. But like if it's slow, do whatever you want. Rhea, what do you have a question or do you have an answer? So what can we factor out of all 3 of these? A 4. And you can take whatever method you want. I know I've been using the common binomial method. But once we get this trinomial, I can do whatever I want. So we get 4 times the quantity of. Okay, so now what method did you take?
I did the one that you showed the first, like when you first did the homework on the board.
Was it the boxes or the X or the...
The tree.
Yeah, oh, so today's first one.
Yeah.
So you take your A and your C and you get
10x squared.
negative 10x squared.
10x squared.
Okay, so from there,
Then I got 2x squared plus 1x minus 10x minus 5.
so 2x squared minus...
Plus x minus 5.
Is anyone confused on how we end up at the negative 10x plus 2? These are the factors of this value, or not plus 2. So that would make your negative 10x squared. So would negative 5x and a 2x, but those won't make my negative 9. So that's why this doesn't work. We could list out all of the factor pairs if we want. Normally only one of them works. There might sometimes be 2, but normally there's only 1. So that's how we get our negative 10x and our x. But those aren't multiplying, they're actually adding. From there, Rhea,
I actually switched the x and the negative 10x, but that's
you switch the... Oh, so you're... So, let's play with this and see, does that matter? So Rhea had these in the other order, but if we keep our order that we have, let's see what happens. If I go to factor my x and my minus 5, yeah, it's just x minus 5. No, so wait, what would have factored out?
That's a good thing.
A 1. This is where people are like, there's nothing to factor. Well, you can always factor a 1. So that's a positive 1. Can I get this to be x minus 5? What do I factor out? 2x. So did you, in the method that you solved it, get 2x plus 1 and x minus 5? Same answer. Whichever order those middle terms are in doesn't make a difference. It'll change potentially how easy it solves. But yeah, it doesn't change what answer you get. Now, if you wanted to write this in another form, if it told you write it as just a binomial times a binomial, to make sure that we're all clear on this, what would the binomial times binomial form of this be, Michelle? Sorry, can you speak up? Michelle applied the 4 to this parentheses, but it doesn't matter because multiplication is commutative. We could move this around, apply that distribution, and still get that. So it could be 4x minus 20 times 2x minus 1, or it could actually be 8x plus 4 x minus 5. So actually what we see there is we can get two different sets of binomials that would multiply together to give you the same trinomial. Other questions? Yeah, Ethan?
I got 8x minus 4 times x plus 5.
The minus 4 and the plus 5 are going to
Cancel out.
goof you up.
Wait, were your
Hold
X's,
on.
Were your X's negative?
Yeah, hold on. So did you still have 8x?
Yeah.
So you had 8x minus 4, and this 8x was positive? And then you had x plus 5. Here's the issue. Your outside gives you 40x. Your inside gives you negative 4x. That'll give you a positive 36, as opposed to a negative 36. So you've got the wrong sign there. Does that make sense?
Oh yeah, I thought that was possible.
So you didn't get a dramatically different result, but what you did really, I forget what direction it would be because I need to get deeper back into these, but your shift would have been a opposite direction. Like the sign issue that you had, it would have moved my parabola the opposite that I wanted to. I forget which, left, right, or up, down. But. All right, that is where we will wrap today. So tomorrow we will start with questions from this homework. So we'll start with 11-6 questions. Yes?
We only do half of the homework.
I'm considering.
If you
That
reach
is
a
true.
point that you feel very comfortable with what you're doing, because I'm not in this for how much work can I make you do. I'm in this for we need to master this understanding. So if you reach a point you're like, I got this, I'm just repetitive at this point, I understand the process completely, then okay. But do not say, I'm lazy and I want to give up, I understand this. No, you gotta actually understand it. But a minimum, you gotta have at least half of them
Are
done.
you here for exams?
Me, I have a meeting, VLT meeting, but if you come right at the beginning of break, I'll be here. But I gotta be in the office by 3:45. It stands for building leadership team. There's also TBTs, which are teacher-based teams, and all sorts of other acronyms